Hi everyone, welcome. Today's class is part 9 of general organic chemistry. In the last class we have discussed about heat of hydrogenation and about the conjugation stability of conjugated systems, stability of alkenes. In this class, steric inhibition of resonance. This class is very small class because today my health is not well, so that's why I'm making a very small video. Okay, so steric inhibition of resonance. Steric groups means bulkier groups, right? Inhibition means stopping. Inhibition means stop. Inhibition means stop. Resonance, you already know about the resonance. I have already discussed about the resonance. So this is nothing but your steric inhibition of resonance. What it means? The resonance will stop because of the steric groups. Because of the steric repulsions, resonance will stop. This is called steric inhibition of resonance. I will give you one example. For suppose I am there, right? I am moving in one road. Man lo that road is my plane. That means I am moving in one plane, right? For suppose if other person is coming from the opposite side to me, other person is coming from the opposite side to me. If the size of other person is large, if the size of the other person is large, if he is the large size person, then automatically I have to change my direction. I have to give side to him, so that now initially I am on plane. Okay, to give side to him, to give some space to him, my direction has been changed like this. Yes. So now when the moment when I'm turning like this, now I'm not on plane, so that I cannot move forward. Clear? Yes. Now my movement depends on the size of the other person. Size of the other person. Same thing happens here also. Same thing happens here also. I will clear you by taking one example. The example here is, first example, aniline, not aniline, and methyl aniline, right? Acha. For suppose if at ortho position I have methyl group, at ortho position if I have methyl group, this group is nothing but me. This group is the opposite person. Opposite person size is very high. So here initially this group is on plane. When resonance will happen? Whenever all atoms are on plane, then only resonance will happen. You know this. This carbon, every atom should be on plane. Then only pi bonds can form. In the same way, this nitrogen group should be on the same plane to participate in resonance. Initially this will participate in resonance if you don't have this group. If you don't have this group, this lone pair will participate in resonance. Whenever you have this group, because this is the bulkier group, there is hindrance between this group and this group, right? Hindrance will create between the group which is at ortho position and this main group. So because of this steric repulsion, we can say, because of the hindrance, we can say, what happens? This lone pair, this group will change its position. Okay, like me, like when I'm changing like this, right? My direction is changing like this when opposite person is coming towards me. In the same way, this group is also changing its direction. Initially this group is on plane. Now after repulsion, this might come above the plane, might come on above the plane or below the plane, so that whenever this is not on plane, this lone pair will not participate in resonance like this. That means resonance will stop. So this is the concept of steric inhibition of resonance. Only thing you have to remember, if you have large group at the ortho position, because of the steric hindrance or steric repulsion, this group, the main group, will not participate in resonance. This is called steric inhibition of resonance. Okay. Now, for suppose I'm having this molecule. That means here I have NCH3. Here one CH3 group is there. That means one person, and another person is also there here at this ortho position. This is ortho position, this is ortho position, you know this. If two persons are there, then what happens? Hindrance will increase. If two persons are coming from the opposite direction, hindrance will automatically increase. When hindrance will increase, steric inhibition of resonance will increase, right? So resonance is not at all possible here. Resonance is not at all possible here compared to first one. So this is the first one. This is first one, right? Compared to this one has more steric inhibition of resonance. Third molecule. First, suppose if I have NH2 group here, CH3 group here, tell me, is there any steric inhibition of resonance there here? Answer is no. Steric inhibition of resonance is not there. Why? Here this is the bulkier group. Okay, but this group is not bulkier. The main group is not that bulkier. Here hydrogens are there. If I have CH3 in place of hydrogen, then repulsion will be high. Whenever I have the hydrogen only, whenever I have the NH2 group, this will participate in hindrance. Hindrance is there, but small hindrance. So not significant hindrance. Because of that reason, here steric inhibition of resonance is not there. For suppose I am here. Okay, I am a very small person. Opposite person is a bigger person. Okay, so whenever opposite person is bigger person, whenever I am the small person, there will be no effect. I don't need to give so much space to him, right? Because I am small, he can go over me, right? So that's the reason why here steric inhibition of resonance is not there, here, right? So 1, 2, 3, 1 is greater than 2, 2 is greater than 3 in terms of steric inhibition of resonance. Clear? The concept is clear? Okay. Acha. Now I'm giving the examples here. For suppose I'm giving this example. C triple bond N, or in place of this I have this group C triple bond CH. Here any group, bulkier group is there or small group is there, hydrogen. I am asking you, steric inhibition of resonance is there or not here? No. Answer is no. So the reason is, here this is the bulkier group, no doubt, but this group is sp hybridized group. This carbon is sp hybridized carbon, and this carbon is sp hybridized carbon. 1, 2 sigma bonds, 1, 2, so sp. So whenever we have sp hybridized carbons, sp hybridized groups, they are linear groups. They always on plane. Okay, so no matter which kind of group you have here, right? No matter, irrespective of the nature of the group, even this is the bulkier group or not bulkier group, this group will not change its position. Okay, this is the exceptional case you have to remember. So in this case, steric inhibition of resonance will not be there. Next one. For suppose halogen. If I have halogen, any halogen, fluorine, chlorine, bromine, iodine, and here any group CH3, bulkier group or small group. In this case also, halogen is very small group. So this group don't need to give some space to this group, right? So repulsion will not be there. So whenever repulsion is there, steric inhibition of resonance will not be there here also. Okay, next one. For suppose I have this one, very important example, SO3H, right? Acha, here CH3. For suppose if you observe, it is looking like a bulkier group. right? But in the actual sense, steric inhibition of resonance is not there here too. Why? What's the reason? देखो, here 1, 2, 3, 4. This is sp3 group. sp3 group means pyramidal. sp3 hybridization. Whenever we have the sp3 hybridization, it is a pyramidal structure. So the structure will be initially this group like for suppose this OH is on top, this O is on bottom, right? Tetrahedral structure. In fact, sp3 tetrahedral. So whenever we have the tetrahedral, 4 groups are there, right? So one group is on plane, one group is on top, next group is on bottom, next group is on plane. So 2 groups on plane, 2 groups on top and bottom. So whenever the group is on top and bottom, so this group is on plane, obviously there will be no hindrance, right? To create hindrance, these 2 groups should be on plane. So because of the tetrahedral structure, this group is not on plane, so this will not create any hindrance, so that this will not show any steric inhibition of resonance. Achha. Next, one trick is there. Alcohol is the friend of amine and alkoxide. That means alcohol OH, amine NH2. Alcohol is the friend of amine and alkoxide OR, OCH3. These 3 groups also will not show any steric inhibition of resonance. You have to remember. Okay, by remembering this trick, you can remember NH2, OH, OR. If these groups are in this position, these groups will not show any hindrance, okay, will not show any steric inhibition of resonance. Okay, so which groups will show then? That's the question, right? Which groups will show? So I will give you 3-4 examples. So the group, this will show COOH or COOR. Here bulkier group, right? Here bulkier group. Next example, in place of NH2, if I have any CH3 group or 2 CH3 groups, okay, that will also show steric inhibition of resonance. This is the second example. Third important example is NO2. Here CH3, right? So these groups are important groups. Okay, these groups will show steric inhibition of resonance. Okay, you have to remember these groups. So this is about the steric inhibition of resonance. So the conclusion is whenever you have, okay, generally whenever you have bulkier group at ortho position in general, okay, so this will create hindrance or repulsion with the main group, so that the resonance of the main group will stop. So this is called steric inhibition of resonance. Okay, so this is about the today's video. Thank you so much for watching.